We know there are two ways to transfer energy. The first one being heat transfer, where energy is transferred by heat from an object of high temperature to a different object of low temperature. A second way to transfer energy is by doing work. We know work is movement over a distance. For example, if you are pushing an object over a distance, then you are transferring energy from you to the object by work. Okay, so now let's take a look at the diagram. For example, this diagram is a piston cylinder assembly, which is a simplified version of the engine in the car. When you burn the gas will expand, and then the pressure P will start pushing the piston to the right. The cross-sectional area being pushed of the piston is equal to A. The horizontal direction is our x-coordinate. So we want to know how much work is generated by this gas because the gas is pushing the piston over a distance. To calculate work, we can use the equation we learned from physics class, which is force dot product distance. Force is a vector, dot product distance. This is how we calculate work. A dot product of two vectors is a scalar, so work is a scalar. It does not have any direction. Okay, how do we perform dot product? It will be the magnitude of the force multiplied by the magnitude of the distance and multiplied by cosine theta. Theta is the angle between the two vectors, force and distance. The direction of my force is obviously horizontal to the right. And then the direction of my distance is obviously the same, horizontal to the right. So what is the angle between those two vectors when they are parallel to each other? The angle between them is theta, and it must be equal to 0, since they're parallel to each other and they're both pointing to the same direction. Okay, and we know cosine 0 is equal to 1, so this equation will be simplified to the magnitude of the force multiplied by the magnitude of the distance, and then multiplied by cosine 0, which is equal to 1. And next, we know force is equal to pressure multiplied by area. So we're going to replace the force with pressure times area times distance. Okay. All right, let's take a look. As the gas expands, what's going to happen to the pressure? Will pressure remain constant or pressure will start to go down as the gas expands? So pressure will actually be going down as expansion happens. So this P is not a constant. That makes the calculation more difficult because there's no way we can replace P with a definitive number since it is not constant. Okay, if this P is not constant, there's no need to fret. All we need to do is to change multiplication into integration. So this equation will just become integral P a derivative of the distance. Okay, all right, and then let's continue. Integral P times A, and the distance, the movement is along the x-coordinate, so we can simply change the distance to x. All right, next, we know the cross-sectional area is a constant, so I am going to move the area behind the derivative. So this equation becomes integral P times derivative AX. And now let's take a look. What is A times X? A is the cross-sectional area and X is length. What does cross-sectional area multiplied by length give us? We can check the units, which will give us some insights. The unit for cross-sectional area is meter squared. And then the unit for length is meter. Altogether, the unit is meter cube. Obviously, it tells us A times X is just equal to volume. Okay, so this equation can then be again written to P times derivative of the volume. And that's our final solution for work. Left-hand side is still W. And the right-hand side is integral P dV, where the lower limit should be the initial volume V1 and the upper limit should be the final volume V2. This is the equation we can use to calculate expansion or compression work in this class. And just like heat transfer, we have rules regarding the signs. If the system generates work, then this work must be positive. If the system consumes work, then this work must be negative. One example is if you are pushing something, then you are the one to generate work. The work will be positive. And if something is being pushed, then this object is the one to consume work, and the work will be negative.